In this video, I'll show you how to build an in-memory message bus using .NET channels. We're also going to create an abstraction for publishing integration events, and this will allow us to switch from an in-memory message bus to a proper message bus in the future. I've got a simple use case here for removing a workout from the database. We fetch the workout from the repository. If it's null, we return a failure. Otherwise, we're going to end up deleting the workout from the database. Now, let's say we want to expand this to also publish an integration event after we are done persisting the changes in the database. Let's start with a simple implementation leveraging MediatR. And I'm going to start by creating my workout removed integration event. This is going to be a record instead of a class, so that I can use the primary constructor feature, and it's going to have the workout ID as the only property. I'm also going to implement the iNotification interface just for the time being, and what we want to achieve with an integration event is tell other components in our system, and this is more common in a distributed system where you have multiple services listening to events, and the integration event is there to tell the other services that something happened. Now, this can also make sense inside of a monolith. If you are implementing the modular monolith architecture, you may want to use integration events to communicate between your modules. I'm planning to move this solution into a modular monolith anyhow, so this is just a good excuse for me to add integration events. Now, I'm going to temporarily inject an iPublisher interface. This is an abstraction from MediatR that allows us to implement the publish-subscribe pattern. And all you have to do is say publish, create a new workout removed integration event. We're going to give it the workout ID, and I can also pass in a cancellation token. So it looks like we already added support for publishing our integration events, but this isn't really asynchronous, and I'm going to show you that this is the case by adding a handler for my integration event. It's going to be called the workout removed integration event handler, and I'm just going to implement the iNotification handler interface for my workout removed integration event. This interface has just one method, and all I'm going to do here is say return task delay, and I'm going to delay this for 5 seconds. When the handle method is awaited, we're going to trigger the 5-second delay. So let's go ahead and demonstrate this, and I want to show you what I mean when I say that this isn't asynchronous. I'm going to run my post endpoint to create a workout instance, and then I'm just going to grab this ID and use it in my delete endpoint, which is going to end up publishing our integration event. So let me send this to my API, and you will see that I hit the breakpoint inside of my remove workout command handler. So let's press continue, and the workout is now deleted from the database because the call to save changes has completed, and now I want to go ahead and publish this using MediatR. So I'm going to press continue again, and we're going to land in our handler, which is what we expected, and now we're going to delay the execution for 5 seconds. And now watch what happens when I press continue. So you can see that we are waiting for 5 seconds. The request is buffering in Postman, and only now I get to the breakpoint inside of my handler, which is going to return a success result, which means that we are basically waiting for our handler to complete when we publish the integration event using MediatR. So if I hit continue here, we're going to get the response back in Postman, but you can see how this isn't really asynchronous. This might seem confusing because I'm using async and await here, but what would make this truly asynchronous was that the execution of my handle method completes as soon as I publish the integration event. And then the integration event should be handled in the background asynchronously from my main execution thread. So let me show you how we are going to implement this using channels in .NET. I'm going to start by creating a few abstractions, and let me create a folder called events. I'm going to add an interface that's going to allow me to publish my integration events, and let's call this the iEvent bus. I'm also going to add my integration event interface, so it will be integration event. I'm going to make it implement the iNotification interface so that I can still call my handlers in the background using MediatR, but the actual publishing of the integration event from my use case will be asynchronous. I'm also going to give the integration event an identifier so that we can track it, and then my iEvent bus interface is going to have just one method called publishAsync, which is going to be generic, and the generic argument will be an integration event. It's also going to support cancellation, so I'm going to add a cancellation token, and I'm going to add a generic constraint on this method that the T generic argument should be a class, and it should also implement the I integration event interface. I'm going to move my integration event interface into its own file, and while I'm here, let me add an abstract record, which is going to be my default implementation of the integration event, and it's just going to have the ID property. This will make it slightly simpler for me to implement my integration events. Now, if I go back to my initial integration event, let's make it implement the integration event base class, or rather record. And what we are missing here is the ID of this integration event so that we can pass it to the base constructor. I also need to update this in my use case. So now I need to pass in a value for the integration event ID, and I need to update this to use my iEventBus abstraction. So let's go ahead and inject the iEventBus. Let's rename this from publisher to EventBus, and we're going to be calling the publish async method instead of the publish method from MediatR. This completes the refactoring to make this use my custom event bus, and now I need to implement this abstraction inside of my infrastructure project. So let's go ahead and close this down, and I will move to the infrastructure project where I'm going to create the events folder, and let's add an implementation for our event bus interface. I'm going to implement the event bus interface in this class, and all I need to do here is to publish this integration event somehow and make this asynchronous so that my integration event is handled in the background. If you were paying attention, I already revealed the secret of how we're going to do this, and I mentioned that we would use .NET channels. Channels are an abstraction that allow you to implement an asynchronous publish subscribe pattern. So I'm going to create an in-memory message queue, and this class is going to use channels under the hood. I'm going to create a private read-only field, and the type of this field is going to be a channel. Channels can be generic, and you can specify the message type that this channel is going to contain, and let's specify the iIntegration event interface. Now I'm also going to assign this channel a value by saying channel and then create unbounded, and I'm going to specify my iIntegration event as the generic argument. An unbounded channel means that it can be used by any number of readers and writers concurrently. If you don't want to support this, you can create a bounded channel where you can configure the number of reader and writer processes. So let's continue with an unbounded channel, and I'm going to expose the channel reader and channel writer values on this class. So let's make a property, and let's, for example, expose the channel writer. It's also going to have the iIntegration event argument, and let's call it writer. The value is going to come from our channel private field. I'm going to do the same for the channel reader. I'll specify the integration event argument, and let's call this the reader, and the value is again going to come from our unbounded channel. And then how are we going to use this? Well, I'm going to configure this as a singleton with dependency injection, and now I can inject this from my event bus, and for example let's call this the queue, and I can use it inside of my publish async method to write an integration event to the channel. So I'm going to say await queue, and then I can access the writer, and I'll call the write async method, and now I can pass in my integration event and the cancellation token, and this is going to asynchronously write the value to this channel. Now all I need to do is to implement a consumer that's going to read the messages from this channel and publish the integration events using MediatR. So let's go ahead and move the in-memory message queue into its own file, and I'm going to add one more class inside of this folder, and I will call it integration event processor job. So this is going to be another internal type, and it's going to be a background service. So I'm going to use the iHosted service abstraction to implement publishing of my background jobs. I'm going to inject a few services into my background job, and the first one is going to be my in-memory message queue. Then I'm going to need the iPublisher from MediatR, and lastly I'm going to add an iLogger so that I can add some logs to my background job. So let's call this the logger. And then the implementation of this is going to be interesting. We're going to use our in-memory message queue to access the channel reader. The channel reader exposes a read all async method, which returns an iAsync enumerable. We can call this method to asynchronously read from our channel in the background. How you actually consume an iAsync enumerable is from an asynchronous for each loop. So we're going to be iterating over iIntegration event instances, and we're going to get them from the read all async method. And then inside of the loop, let's add an information log. Let's say publishing and, for example, integration event ID as the argument, and I'm going to pass this from the integration event instance. Then I'm going to actually publish this integration event using MediatR, and this is just going to execute my handler. And lastly, I can add another information log, and let's say processed, and then the integration event ID. And of course, I need to provide the value for my structured log. What I'm not taking into consideration here is what happens when the publishing fails. What we could do is wrap this into a try-catch statement, maybe even repeat the publish a few times if it fails, and lastly, we could write the integration event to some sort of dead letter queue if we fail to process it even after a few attempts. But I'm not going to get into that in this video, and let me show you a few more things we need to do to make this actually work. So now I need to register my services with dependency injection, and I said that I would register my in-memory message queue as a singleton. We can also do the same for our event bus because it's a stateless service. So let's specify the event bus, and let's add the hosted service, which is going to be our integration event processor job. And now let me show you how this changes the behavior inside of our command handler when we publish the integration event. I'm going to create another workout, and then I'm going to use this workout ID to remove it right away by calling the delete endpoint. So let's send this to our API, and I'm going to hit the breakpoint inside of the remove workout command handler. I'm not going to add any other breakpoints in my use case, so let's press continue, and you will see that we land inside of the event bus, where I'm going to write the integration event to the in-memory message queue. So I'm going to also press continue here, and you will see that we enter the for each loop inside of our background job. So let's try to publish the integration event. I'm going to press continue, and now we're going to land inside of our integration event handler, which is going to delay the execution for 5 seconds, but I also added a breakpoint to the information log right after handling this event. So let's press continue here, and what you can see here is that I got the response back in Postman while the handler is still executing in the background. Now if I go back to Visual Studio, you will see that I hit the breakpoint after publishing my integration event, so my debugging session is still alive, but I got the response back in Postman, which means that the publishing of my integration events is now asynchronous and the integration event handlers run in the background. This is all made possible using channels, which allow us to implement asynchronous publish and subscribe, but the caveat is that this only works in a single process, which is why I called this the in-memory message queue, and this should make it obvious that this implementation is only going to work inside of a single process. So it might be suitable for a modular monolith implementation, although you do run the risk of losing messages because this implementation isn't reliable. And if you wanted to switch to a proper message bus, for example RabbitMQ, then all you need to do is to update your implementation of the event bus class. If you want to learn more about distributed messaging with RabbitMQ and mass transit, then you should watch this video next. Make sure to smash the like and subscribe buttons under this video, and until next time, stay awesome.